Hello and thanks for watching. We are going through Unit 6 Day 1 notes for Algebra Honors. Whoops, I just made that not the right size. Unit 6 Day 1 for Algebra Honors. Unit 6 is our unit on exponents and radicals, and here we are beginning the unit with some quick reminders about what exponents even mean, and then we're going to talk about what do you do if your exponent is 0 or if it's a negative number. All right, and so looking at this example right here, if we have 5 to the third power, we are saying that our base of 5 is going to be multiplied by itself 3 times. And so that means 5 times 5 times 5. So I'm going to use similar examples to what we have in this chart right here, but I'm actually going to kind of go off-road here for a minute just because I prefer to show this information in a different format, and then we'll come back and show how mine relates to this one. We are talking here with 3 to the third, 3 to the second, 3 to the first powers, and I'm going to do that same thing. I'm just going to do it vertically instead of horizontally. So starting fresh, if I have 3 to the third power right here, 3 to the third power. What that really means is I'm going to multiply the base 3 times itself, the number of times indicated by that exponent. So it's the base of 3 times itself 3 times. 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. Okay, my next item is 3 squared, 3 to the second power. So notice that I've decreased my exponent by 1, right? I went from 3 to 2. Exponent minus 1 is what we're doing here. Okay, what this means is 3 times 3, and 3 times 3 is 9. I'm going to decrease my exponent again, so I'm going to say 3 to the first power, and I now just have 3 hanging out right there. Okay, and of course 3 is 3. All right, so look at what's happening here. Every time I decrease my exponent by 1, I'm dividing by 3. I'm dividing by the base every single time. So when I decrease my exponent again, I'm dividing by the base again. So if I know that I'm going to look at 3 to the 0, because I'm decreasing my exponent again, right? I have 3 to the 0. What is that going to be? Well, I'm going to divide my last result, 3, by 3. 3 divided by 3 is 1. So this works with every single number, right? If I were to come over here and say 2 to the third, that's 2 times 2 times 2, that's 8. 2 squared, I've just decreased by 1, so I only have 2 times 2 this time. That is going to equal 4, which happens to be 8 divided by 2, my base. 2 to the 1 is just hanging out there as 2, so I divided 4 by 2. Again, I divided by my result previously by the base. 2 to the 0. I'm going to say 2 divided by 2. 2 divided by 2 is just 1. Okay, so no matter what your base is, any base to the power of 0 equals 1. Except if your base is 0. You are not allowed to divide by 0. So if your base was 0, 0 to the 0 is just kind of nonsensical. You can't do that. Okay, so back to our 3's, right? We're going to decrease by 1 with our exponent over here. So 0 minus 1 is just 3 to the negative 1, right? All right, I'm still dividing every time. I'm dividing by 3. 1 divided by 3, let's just write that as a fraction. Okay, so I'm going to divide again, right? I'm going down 1 exponent, so I'm now at 3 to the negative 2. And so I have 1/3 divided by 3. Let's pause for the briefest of moments. 1/3 divided by 3 right here really means 1/3 divided by 3 over 1, which really means 1/3 times 1/3, right? Because you keep your first fraction, change to multiplication, and flip your second fraction. Well, I'm using exponents, and so I actually could say that this is 1 over 3 squared if I want to, because 3 times 3 is really 3 squared. Or I can say that that is 1 over 9. So I'm saying it's 1 over 3 squared on purpose because, look at this, if it's 1 over 3 squared, The connection you can make here is if I have a negative exponent, I'm going to put my information into the denominator, and I'm going to make my exponent positive. Okay, 1 over 3 squared is also equal to 1/9. So both of those are true. If I want to go one more, 3 to the negative 3, then again, I'm going to make my exponent positive. I'm going to put it in the denominator, so it's going to be 1 over 3 cubed. And we know 1 over 3 cubed is 1 over 27, because we know 3 cubed, 3 times 3 times 3 is 27. Okay, so very quickly I'm going to do that over here too. 2 to the negative 1 is going to equal 1/2. Okay, I divided 1 by 2 and I got 1/2. 2 to the negative 2 is going to be 1 over 2 squared, right? I put all of this in the denominator and I made that negative become positive. And I also know 1 over 2 squared is 1/4. Okay, so that's a whole lot of information, but it's also the same information that you can see right here in this chart. Okay, 3 to the third, we're decreasing our exponent by 1. We go to 3 squared, 3 to the 1, 3 to the 0, and so on. And so you can see that we went from 3 to the 0, which is 1. When we divided by 3, we got 1/3. When we divided by 3 again, we actually got 1 over 3 squared, which equals 1/9. And when we divided by 3 yet again, we got 1 over 3 cubed, which equals 1 over 27. Okay, so just proof of why anything to the 0 is 1, and proof of why we get to rearrange when we have a negative exponent. We get to rearrange and make fractions out of our work. So for every non-zero number, a to the 0 equals 1. Okay. And again, the reason you can't have 0 to the power of 0 is back when we were dividing always by the base. Here, when we're dividing everything by 3 each time, we're dividing by the base. If your base is 0, that would mean you're dividing by 0 every time, and so the whole world implodes because you're not allowed to do that every single time. Okay, so let's do some practice. Anything to the 0 is what? 1. So m to the 0 is going to be 1. Doesn't matter what m is. It equals 1 right there. Okay, anything to the 0 is what? 1. So this amount inside here equals 1. Here, though, I need to take the negative of x to the 0. Right? Be careful about this. We need to be careful about where that negative is. This is the negative of x to the 0, so it is negative of 1. That is negative 1 for that answer. This is the negative of 6 to the 0, so that is negative 1. This, if I use order of operations, GEMDAS, I have to do my exponent first and then multiply. So it's going to be 2 times 1, which is 2. And here I have negative 5 times k, all to the power of 0. And so when I work that out, and I'm going to work you through this, okay, if I had this amount, negative 5k squared, if that's what I had, that really means negative 5k times negative 5k, which really means, slide that over, negative 5 times negative 5 is 25, positive, right? And k times k is k squared. Okay, if I now want negative 5k, that amount, to the first power, I am dividing by the base. The base is everything inside that parentheses set. So I'm dividing by negative 5k. 25 divided by negative 5 is negative 5. K squared divided by k is just k. And so negative 5k in parentheses to the power of 1 is negative 5k. I'm going to divide again by negative 5k because that is my base. So now when I have negative 5k all to the 0, negative 5k divided by negative 5k equals 1. Anything divided by itself is 1. So when we look here, negative 5k all in parentheses to the power of 0 equals 1. Just be really careful with negatives and parentheses. We'll do lots of practice on that. This guy's different because I'm having -5 times m to the 0. So GEMDAS tells me I have to take care of m to the 0 first, so I have -5 times 1, right? M to the 0 is 1. -5 times 1 is just -5 there. And over here, the negative of -7 to the power of 0, that's going to be the negative of 1, and that's our final answer. Okay, so now we get to have some rules here with our negative exponents. So there's a negative exponent rule. If I have a non-zero number a, and it's raised to a negative power, a negative n, I can rewrite that, a to the negative n, I can rewrite it as 1 over a to the positive n. Okay, so I am making this negative exponent move from what was originally the numerator, if you had a fraction there. I'm going to move that whole term, a to the negative n, into the denominator and change the sign. Okay, we showed why that works just a moment ago, but that's our rule. So a negative exponent is just defined as the multiplicative inverse of the base raised to the power, which is opposite to the given power. Lots of words. Let's just do some more practice here. So if I have 7 to the -3, that is originally 7 to the -3 over 1. So 7 to the -3 is in the numerator. If I move the term into the denominator, I get to change the sign of my exponent. All right? If I have this amount, -5 to the power of -2, I'm going to move -5 to the basement down here, right? I'm going to move it to the denominator, and I'm going to change the exponent so that it is positive. One last time, if I have x to the -4 here, I get to make -4 +4 if I put that term into the denominator. Likewise, and there are sometimes reasons you might not do this, but not normally, if I have, I don't know, m to the 3rd, if I put that in the denominator, it would be 1 over m to the -3. Okay, it works either direction. You're just going to switch the sign. I don't know why we would do that. I just want you to know that it does work either way. All right, so again, you can't use 0 as a base with a negative exponent because you can't divide by 0. You're not allowed to. All right, so let's take a look. Right here, we're going to write each one of these expressions in simplest form. So maybe do the first couple with me and then put this video on pause and come back and check your work and see how you're doing. 4 to the -3, I'm going to put 4 to the 3rd in the denominator. Okay, 1 over 4 to the 3rd, and if I wanted to use a calculator to do that, or my mental brilliant brain, 4 times 4 is 16, times 4 again is 64. Okay, an algebraic expression in its simplest form when the powers with a variable base are written only as positive exponents. So this is the big takeaway. We like positive exponents when we are doing our math. We don't want any negative exponents. All right, let's look at this, number 2 here. It says 5 times s squared times t to the -1. So 5 is still happy. If that's all over 1, 5 is happy and doesn't have a negative exponent, right? Because it really has an exponent of +1. So 5 is going to stay in the numerator. S squared is happy. That has a positive exponent. We're going to let s squared stay in the numerator. T to the -1, t's feeling a little negative and t would like to move to a different location. So what we're going to do is let t move to a different location. 5 stays in the numerator and s squared stays in the numerator. We're going to put just t to the -1 down in the denominator, and it becomes t to the +1. I don't need to write +1, I can just write it as t. Okay, this is the negative of 3 to the -2. So I know my answer is going to be the negative of 1 over 3 squared. Okay, which is, oops, I'm sorry, you can't see what I just wrote. It is the negative of 1 over 3 squared. So that's really just -1/9, right? Okay, you have to take care of the thing that has the exponent first. So the thing with the exponent is 3. 3 has an exponent of -2. I'm going to make that 3 to the -2 have a positive exponent. And so I have -1/9. So I suggest you pause, try a couple of these, and you can come back to the video and kind of skip forward to the ones you're curious about, check your answers, and make sure you're not losing any negatives. You got to be super careful of those negatives. All right, so good luck. Come back and check your work. Okay, when I look at number 4, this is 4 over x to the -3. So right now, x has a negative exponent. I don't want a negative exponent. So in order to change the sign on my exponent, I'm going to change that guy's location. So I'm going to move x to the -3 somewhere else. All right, he's going to move up to the attic. Well, I already have 4 up here. And so if I put x to the -3 up into the numerator, it's going to be x to the +3. And it ends up being 4 times x to the 3rd. So just a quick explanation on that, and you can fast forward if you don't need the quick explanation on that. This really means 4 over x to the -3 really means 4 times 1 over x to the -3, right? That is literally what that means, because if I were to multiply this back out again, I would get 4 times 1 is 4, 1 times x to the -3 is x to the -3. So if I know that 4 over x to the -3 really means 4 times 1 over x to the -3, oh my goodness, I'm sorry, you can't see. If I know that 4 over x to the -3 equals 4 times 1 over x to the -3, then I can just deal with this part and fix my exponent. So this really equals 4 times, I'm going to put x to the -3 up in the numerator, so it becomes x to the 3rd. Okay, all right, I will try not to do that too many times for you. Let's take a look here. I have the number -4 to the power of -2, and so that is really 1 over that -4 squared, which is the same as 1 over -4 times -4 gives me +16. Okay, here I have 5 times a to the 3rd times b to the -2. 5 has an exponent that's positive, right? It's a positive 1, it's just invisible. A has a +3, so 5 and a to the 3rd don't need to move. They are perfectly happy where they are. So we're going to keep them in the numerator, 5a to the 3rd, and b to the -2. I'm going to put that in the denominator and make it b squared. All right, 1 over x to the -5, I'm going to change its location and change its sign. So that is move it to the numerator, we have x to the 5th. And I say move it to the numerator, and you notice that I didn't give us a denominator. That's because our denominator is 1, so we wouldn't need to write that. All right, 2 over n to the -3. I'm going to move n to the -3 into the numerator. And remember, that means that I'm saying 2 times n to the 3rd. 4 times c to the -3 times b. The only thing that's unhappy here, and of course, you know I'm being silly when I say unhappy, numbers aren't unhappy. This is really 4 times c to the -3 times b. The only thing that has a negative exponent here is this middle part, c to the -3. So I'm going to keep 4 and b in the numerator, and I'm going to put c to the 3rd in the denominator. I put it from the numerator into the denominator and change the sign. All right, n to the -5 over m squared is really going to be n to the -5 times 1 over m squared, right? And so I want that to look like 1 over n to the 5th times 1 over m squared. The only thing that had a negative exponent was that n. And I can now simplify that. I know my numerator is 1 times 1, which is 1, and down in the denominator, I'm going to be alphabetical, so I can say m squared n to the 5th. All right, and as always, if you catch me making mistakes that I don't correct, by all means, send me an email or stop by, and there might be a Jolly Rancher in it for you. Okay, here 6a to the -1, c to the -3, all over d to the 0. Well, that's a mouthful, but d to the 0 equals what? 1. That's it. Anything to the 0 power is 1. And we are assuming, you are assuming, that if I give you a variable in the denominator, that it's not 0. Okay, just assume that, please. All right, so here I have 6 times a to the negative 1 times c to the negative 3. I'm going to keep the 6 in the numerator because it has a positive 1 exponent, so 6 does not move. But a to the negative 1 is going to be a to the positive 1 down there. C to the negative 3 is going to become c to the positive 3 in the denominator. And here, it's just a lot of numbers, but we can handle all of them. 2 has an exponent of 1, 3 has an exponent of 1. Those guys are going to stay in their happy locations. So I keep 2 in the numerator, I keep 3 in the denominator. B to the 7 has a positive exponent, so it's going to stay where it is. X to the negative 3 has a negative exponent, so that's going to move. Okay, and I'm going to try to keep things alphabetical too, so I'm kind of jumping around a little. I know that's going to move. Down in the denominator, I have 3a squared y to the negative 5, so I'm going to keep a squared down in the denominator because it has a positive exponent. Y to the negative 5 is going to have to move to end up with a positive exponent. So let's put x to the negative 3 in the denominator, and it becomes x to the third. Let's put y to the negative 5 in the numerator, and it becomes y to the positive 5. All right, so we'll have a second video for the other part of the notes and the other part of class practice. Thanks again for watching.